the probability of 3Q, right? So the first Q is picked already. So now the second Q, you have only 3. Now, what about the next one?
2
over
50.
Okay, very good. So the top is 24. The bottom is 52 times 51 times 50. What is that?
It is 132,000. I don't know how to read this number, but it's 132. 600.
13200.
Oh, 6. 132 600.
Okay, so you always put a comma here. Okay, every three places, and then this one is 1,000. So you will say 132,000 because it's the thousandth place. Thousandth place. So you say 132,000, then 600. Yeah. Okay, so what do we get for the decimal number?
I got 0.00018.
0.00018?
Yeah, 09.
09?
Yeah.
So which is 0.18%. Yep, everybody? Okay, so now let me ask you a question. So without replacement, it is this way. But with replacement, it is what? It is 4 out of 52 times 4 out of 52 times 4 out of 52. Okay, do you see the difference, everybody? What's the difference between these two, everybody? Can you tell me? About okay, so let me just tell you. The second one, the second probability is affected by the first one when it is without replacement. When the same outcome cannot appear again, the second and the third Q, its probability is affected by the previous. Do you see that? But for the with replacement, the second is not affected by the first one. The third is not affected by the first and two. Okay, everybody. Now I want to tell you one very important idea. If it is affected, like here, affected by previous, affected by the other event, that is called what? That is called dependent events. Two events are dependent if the occurrence of one event affects the probability of the other one. That is called dependent events. Okay, like here, we just say here. Okay, let me just erase everything here. But just for this case, the second one is affected by the first one because you don't put the call back, right? You have only 51 to choose. And then you have only 3 because the first one is already picked. Okay, like this one, it is dependent events. Are you with me? Are we good?
Mm-hmm.
And independent events is this case. This case, what? With replacement, which means what? You put the car back. So the second one is not affected. Not affected by the other events. The second is not affected by the first one. The third still 4 out of 50, not affected by the others. So this is called independent events. Everybody, are we good? Okay, very good.
So I have one question. So with replacement would be an independent variable, right?
Yes.
And without replacement would be dependent.
Yes. Well,
okay.
Dependent is merely just like this one. you will be affected because you are not putting the car back. So the second one will be affected by the first one.
Okay.
Yeah. Are we good? Everybody, are we good? Yep. Okay, so for that property, instead of saying PA and B equals PA times PB, some people want to distinguish the property for independence and for independent dependent situation. So they use this one for dependent situation, dependent. So let's just say PA times PB given A, or you can write it as PA times PB given A. This is the probability of B given A happens. And this is because people want to write this property in another way. It's because just merely want to distinguish that this is for dependent events. But basically they are the same. They are the same. It's always multiplication. Do you see that? It's always multiplication. And you just have to take care of the dependent or independent. You just have to be careful when it is dependent. Like this problem, that should be 3 out of 51. And the third one will be 2 out of 50 because you don't put the car back. That's what you need to take care. That's all. Are we good? Basically, they are the same, okay? Dependent, independent, they are the same. Just multiplication, okay? You multiply them together when it is end. The difference is for dependent, then you have to take care of this situation. That's all. Okay, so let's do this one, everybody. Let's do exercise B. Let's do exercise B. 3 female in a row is just like what? Okay, everybody. So what is the probability for the first one is female?
It would be 2/3.
Okay, can you simplify that one, right? So what is the fraction not simplified?
It's 4/6.
4 over. So remember, the probability is the favorable over the total. What's the total?
Oh, okay.
What's the total?
10.
10, right? Remember, always the probability is the favorable over the total, 10. Now, what about the second is the female? What's the probability?
Same?
Okay, remember, can you pick the same girl that you already picked?
No.
Is the girl still, you put, yeah?
A twin. No.
3? Yeah, because you already picked one woman, right? This is, you pick 3 female in a row, right? So the first one, you already picked female. So the second one, when you pick, you have only 3 left. And then out of what?
Out of 9.
Yes. And then what about the third one?
2 out of 8.
Yeah. So do you see that? Why did I tell you what pattern do you see in different cases? Because it's the same as picking the cars. Do you agree? Yeah, you pick one. You have four women, just like you have four queens, right? And you pick from four out of 10, instead of what? Instead of 52. Now it's 4 out of 10. But the second one, since you don't put the person back, you are picking people from a group of. You don't put the person back, right? Because you are choosing a jury, right? So we just have to make sure we take care of this one. So this is a without replacement situation. This is a without replacement situation, right? Because the same girl cannot appear 3 times. It should be different females. Does that make sense, everybody? Are we good? Mm-hmm. Okay, very good. Now let's talk about the other one. Okay. Okay, I'm not sure why this is not working. Okay, let me share another file to you. Okay, do you see the second part of section 7b? Yeah? Okay. Now, A and B, P, A and B, it will be PA times PB times PC, and you have to take care of what? Independent or dependent situation, right? Everybody? Now, or, then the formula is PA plus PB minus PA and B. Oh, sorry about that. Okay. Yeah, I'm healthy. Don't worry about that. I'm good. I'm good. Okay. Yep. Okay. So remember, this is the formula. A and B, you multiplication. A or B, you add them up, but you minus the A and the B. You minus the PA and the PB. Okay. So let me prove this one to you later, but let's just talk about this problem. Okay. You find the probability if you toss a fair coin twice. Okay. Find the probability. The first one is T or the second one is T. Let's use the traditional way. Let's just use the traditional way to talk about this problem. Traditional way. Traditional way, we say heads, tails, tails, heads, tails, tails, and then we just circle the favorable ones. Okay, so we will say this is number of total and the number of favorable. Okay, so what's the number of total? That's 4, right? So can you circle which one we have? The first is T or the second is T? Which one? Which one should we circle?
Last one?
Yeah. And which one should we circle? Remember, it is not the first and the second should be. It is either first one is T or the second one is T. Then you are good. So what others should we circle, everybody?
Do something else today.
I'm in a class.
Everybody?
Oh, it would be the second.
Yes, the second. Any others?